Okay, we are starting Snowflake architecture today. So, yeah, very important. Of course, whatever I teach, everything is important. Okay, so there is nothing to miss. But I'm telling this here Snowflake class actually starts. So B means basically theoretical stuff. Snowflake architecture means how it is architected theoretically. Okay, so even anything for everything there is a documentation in Google. Okay, if you just come to Google and type in whatever concept you want, okay, so you will get reference documents from the Snowflake itself. See docs.snowflake.com. So that is called documentation. For example, if you buy any product, we will get documentation, right? For example, if you buy freezer or washing machine or anything, operation manual he will provide, means how to operate. So similarly, every product, even AWS Redshift, Google BigQuery, Snowflake, for anything, documentation will be there. So you just need to type, and we will be able to find it. Okay. So actually, this is the standard. Means whatever is there here, actually that is the standard. Okay. So anytime you want to refer anything, you need to come to this documentation for anything. Everything about the product, any new changes or new enhancements or new features, everything will be updated in this documentation for the customers. Means because big customers will be using, right? So they will be referring this. So this is called public documentation. So yeah, anyway, you will come to this later. Okay, so whenever you get time, you can able to read this. So, but now let me explain you architecture. So before going to architecture, there are some basic terms you need to know. I will be explaining. SaaS. SaaS means software as a service. So the Snowflake, even Redshift, these are all software as a service. Means we don't install anything. Okay, he will just give you one URL, and we'll click on that URL. We immediately enter into the software. There we will be able to run queries or whatever we want to do, we can do. Okay, so like that. Earlier, you should have a server room. You need to purchase hardware. You need to install. You need to configure LAN and WAN and system admins, network admins, and you have to install patching softwares. You have to install softwares. So much stuff will be there. So that is called actually on premises. But this is different. You don't even touch anything. Everything will be there ready made. Whatever you want, how much configuration you want, you need to just configure it and use it. That's it. So anyway, we will see that. Okay, so yeah, we already know Snowflake, runs completely on cloud. Okay. Yeah, this, I mean, what is data warehouse? Everything we have covered actually. Yeah. And on what platforms Snowflake runs, I have already said it runs on any of these three public clouds. It may be on Azure or AWS or GCP. Okay, it will run any of these public clouds. Means if you want to use Snowflake, you must be selecting one of these platforms to run on it. As I said, Snowflake don't have its own data centers because it is just a startup. But it will use one of the infrastructure from these cloud providers. These are all called public clouds actually. Azure, AWS and Google GCP. Of course, AWS is the largest one, and then Microsoft Azure, and then GCP. So it will use one of these platforms based on customer. Actually, customers will be selecting like what platform they want while setting up the Snowflake. So generally, the question they will ask is, I mean, Snowflake you used in which environment? Okay, so most of the jobs are Snowflake with AWS and Snowflake with Azure because these are the 90% of the 95% of the market. GCP is very small. It's coming up because the number of data centers are very less in GCP compared to Azure and AWS. AWS has 70% of the market and remaining Azure. Market means even data centers also AWS is very high. Okay. Data centers means their infrastructure setup in every country. For example, in India we have in Mumbai, even in Hyderabad also AWS is setting up, and AWS has everywhere actually. Yeah, like AWS, Azure also trying to set up almost in every country. I'll tell you what are those reasons and all when we go to actual subject. So then, yeah, SaaS means we know because these are the basic terms we need to know. Yeah, because we should not think that I'm not aware of this term because we are going as a real-time employees, so we should be familiar with the terminology. SaaS means software as a service. PaaS means platform as a service. IaaS, infrastructure as a service. These are all cloud terms actually. Okay. So when coming to the Snowflake architecture, actually the question will be, can you please tell me about Snowflake architecture? That is the question, and it's a definite question in every interview. Okay. Um. Okay. So how to answer this? Okay. Yeah, you can start from here. Uh, Snowflake follows hybrid architecture. Okay. So having shared disk and shared nothing. Same here, you see. Snowflake architecture is hybrid of traditional shared disk and shared nothing database architecture. So this point is really, I mean, solid point. Okay. I will explain you what is shared disk and what is shared nothing. Okay. So, but before that, we need to know this statement. Snowflake follows hybrid architecture. Hybrid means combination of more than one. So hybrid. What is that? Shared disk and shared nothing. Actually, all cloud data warehouses are shared nothing. Okay. For example, if you take Redshift or BigQuery, so they are all shared nothing. Okay. Even Teradata shared nothing. MPP architectures are called shared nothing. Okay. So, but here Snowflake has come up with. See, everyone try to invent something actually and try to improve. Actually, the main database in MPP came with Teradata only, but they did some changes. Actually, AWS architecture is similar to Teradata architecture. Okay, but identifying the drawbacks in Redshift means AWS means Redshift. So Redshift is shared nothing. So Snowflake come up with shared nothing but shared disk. Means disk they are going to share. I'll tell you what is that actually. See here. These are all the database layer. Actually, there are three layers will be there in the Snowflake architecture. What is that? Cloud services layer, query processing layer, storage layer. So first point we should tell is Snowflake architecture is based on hybrid architecture. Okay, shared disk and shared nothing architecture. It is based on shared disk and shared nothing architectures. That is first point. Then it has three layers. Snowflake has three layers. Okay, database storage layer, query processing layer, cloud services layer. You can tell from bottom to top, or you can tell okay, cloud services layer, query processing layer, database storage layer. So these layers you should tell clearly. Okay, first point is it is shared disk and shared nothing. Okay, that means it's a hybrid. What is first point? Shared disk. What is second point? Shared nothing. Okay, and it has three layers. What are those three layers? Cloud services, query processing, and a database storage layer. Okay, cloud services layer, query processing layer, database storage layer. Okay, so then we need to explain about each and every layer actually. See here, I will read this actually. Similar to shared disk architecture. Shared disk means disk will be shared actually. Shared disk architecture. Snowflake uses central data repository for persisted data that is accessible from all compute nodes in the platform. That means what he is telling is you will have a disk and it is accessible to entire Snowflake system. Okay, so you will have one copy, but it is accessible to all your cluster. So that is what he is telling. And similar to shared nothing architecture, I already said shared nothing means MPP. Okay, see here. Snowflake processes queries using MPP, massively parallel processing. Okay, similar to shared nothing architecture, Snowflake process queries using MPP means massively parallel processing compute clusters, where each node in the cluster stores portion of the entire dataset locally. Okay, I'll tell you. What is this MPP architecture? MPP architecture is known as shared nothing architecture. In shared nothing architecture, okay, your data is physically stored in disk, right? So this is disk storage. Okay, your physical data is stored, but before that there is query processing layer. These are all like CPUs. You see, these are all CPU. Virtual warehouse means these are all CPUs. Okay, in computer we'll have CPU, right? That one, processing units. CPU is a central processing unit. So here query processing, queries will be processed by CPUs. So here the term is called virtual warehouse. VW, virtual warehouse means they are CPUs, but they are virtual, means they are logical. Okay, and there are so many virtual warehouses. Virtual warehouse means CPUs, okay, computing units. So they will have access to this physical storage, and they will have, local storage also. Okay, so every data that is there, for example, employee record is there, it has 100, employee table is there, it has 100 records. Okay, that 100 records are physically stored in database storage layer. Okay, so let's say you have configured your Snowflake with two virtual warehouses. How many? Two. See, these are virtual warehouses. You can configure how many. I will show you. Okay, when I create that cluster, I will show you. When you have two virtual warehouses, the same data logically present in the two virtual warehouses. For example, you have three virtual warehouses. So the same data logically present in the three virtual warehouses. Or let's say you have four virtual warehouses. The same copy of the data is locally stored within those three virtual warehouses. So that is called massively parallel processing means compute clusters where each node in the cluster stores portion of the entire data locally. Means you have 100 records, right? 100 records will be stored here. If you have four virtual warehouses, four virtual warehouses will store the data equally, like 25, 25, 25, 25 records are stored within each virtual warehouse. Okay, so that is that is called actually distributed systems or distributed architecture. This MPP architecture only is called as distributed architecture actually. Distributed means your data is distributed across computing nodes. Actually here many terms I am using, but those are all used interchangeably. I will tell you. Shared disk, one thing we have used. Shared nothing, second thing we have used. Okay, MPP, massively parallel processing. Actually there is another thing, SMP, symmetric multiprocessing, and distributed systems. Distributed systems. Okay, so actually all the cloud systems are distributed systems. Actually in BTech also there is subject called distributed systems. So distributed systems means your data is not stored in one place, it is distributed across multiple processing units. So that's why this is called distributed system. All cloud databases are examples of distributed systems. So it's a It's a one global term actually, distributed systems. Okay. SMP means single unit is called SMP. Okay. Single CPU or single virtual warehouse. Okay, that is SMP. Okay, so these two you no need to worry about it. Even MPP also. MPP means massively parallel processing. Okay, so single virtual warehouse is called SMP, means symmetric multi-processing. Symmetric multi-processing. Okay, SMP means symmetric multi-processing or single virtual warehouse or single CPU or single virtual warehouse is called SMP. Okay, symmetric multi-processing they call. So earlier, before distributed systems come, everything is stored in single CPU or single node, right? So that is called SMP system. Okay, some traditional means some long ago, where there is no concept of distributed systems are there, or even actually first distributed system or first, okay, shared nothing system is Teradata actually. Okay, so all architectures are based on Teradata only. You take AWS, Redshift, or BigQuery, Snowflake. These are all actually, they copied the Teradata architecture. They made some changes, and they called it innovation. Innovation means take something that is existing, make some changes, and give a new name and make it as your product. That is called innovation. Innovation means whatever is there in the market or anywhere, take it, see what is what is best you can do, okay, by changing here and there or bringing some new features to that. And of course you can name it as your own product and you can release it to the market and you can sell it. So that's what the AWS architecture is same as Teradata architecture actually. Okay, and okay, AWS has come up with its own architecture. Within that, Snowflake also they took, you can say it took the Teradata architecture, or you can say that it took the Redshift architecture. Here the disk is not shared. So in Snowflake architecture, they shared the disk, means they put a common storage for all the compute processing. Okay, which is not there in AWS. That's why it is called shared disk and shared nothing. Means disk is not shared in Teradata or Redshift, so they shared the disk. Means they made available entire storage available to all the nodes. So now they claimed as it is my architecture, so it has all rights to me. So that is called innovation actually. Okay, it is accepted. So yeah, those things we'll read about them again. So MPP means massively parallel processing. That is called shared nothing. Shared nothing. Shared nothing means nothing is shared. Okay. So what is that shared nothing? So this one. See here, virtual warehouses. Virtual warehouses are computing units. I already said they are virtual processors. Means they are like CPUs. So they have their own CPU, their own IO. Okay, their own memory will be there. That's why they are called shared nothing. Okay, each virtual warehouse has its own CPU, its own IO, its own memory. Everything will be there. Similarly, it also will have its own CPU, its own IO, and it also will have its own CPU, IO, memory. Memory means main memory, RAM will be there. Okay, so that's why they are called shared nothing. The storage layer is shared. I mean, shared means it is common disk available for all the computing nodes. Okay, they can connect to and access to every whatever data is stored in the database. That is, it is called shared disk and shared nothing. Shared disk means storage is shared to all the virtual processors. Shared nothing means all the virtual processors are independent. They have their own CPU, they have their own IO, they have their own memory, main memory, like that. Okay, they can process the data independently. You can even configure your Snowflake with single virtual warehouse. Okay, you can have set up your system single virtual warehouse. I will show you in fact everything. So for example, you are configuring dev system, okay, development system, you can just create with single virtual warehouse, okay, to reduce the cost. Or you are setting up QA system, you can set up with only two virtual warehouses. Or you're setting up the prod system, you can set up with some four virtual warehouses. Let's say not four, okay, your workload increased, you want some higher system, you can change the virtual warehouses to 8 or 10, whatever you want. So everything just just a click of a button, not like in traditional on premises. In on premises, if you have to add one more node means, oh my god, it's months and months planning. For example, I worked with Teradata. Let's say we have some four node system. If I have to add one more node, oh my god, we have to plan some 2 3 months ahead. Okay, first of all, we need to make sure we have enough space or not in the server room, and then we have to procure that hardware, and then we have to call that Teradata guy. He has to come physically and add this node to the existing four nodes. Oh, and we have to, keep the production jobs on hold and then add this node and restart that server room with 5 nodes. And then he will bring the system back, and then we need to resume our loads. Okay, it's a really, very, very tough thing, on premises thing. That's why here nothing. In cloud, everything is through you through UI or through URL. You just log into or come to this URL. Just see if you want to add, just add it. How many VP virtual processors you want, just select it, and that's it. Submit. Those will be configured within just fraction of seconds, and your system is ready. Okay, that's why everyone is already moved, and some of them are moving. Okay, so everyone is using cloud now. Okay, so no exception. Nobody is using the on-premises nowadays. Okay, so now all projects are migration projects only from Oracle, SQL Server, even Teradata to either they are migrating to AWS or they are migrating to Snowflake. But Snowflake has become, really the most famous, okay, because of this architecture. That's why this architecture, they actually ask a definite question. Okay, what is Snowflake architecture? Snowflake based on shared disk and shared nothing architecture. Okay, it has three different layers: cloud services layer, query processing layer, and database storage layer. Okay, in database storage layer, all your data will be there, and that is available to all the virtual processors. Okay, and in query processing layer, okay, we will have different virtual processors configured. Okay, so all the VMs or virtual warehouse, not VM, VW, all virtual warehouses are available in query processing layer. They are capable of processing their own data. Okay, they have their own CPU, IO, and main memory, which will process the data. Okay, and the first layer is cloud services layer. Okay, cloud services layer. Cloud services layer, what it will do is, see here, authentication and access control, infrastructure manager, optimizer, metadata manager, security. I will tell you. Okay, authentication and access control. For example, you three are users, and for example, I am also user. Okay, we are working for some X company. Okay, and this is our Snowflake. Okay, so we took the Snowflake account, and Snowflake account, where it is their actual hardware, it's in the data center. Okay, in Snowflake region. Okay, for example, we have taken maybe Mumbai region, or if you are US customer, let's say you have taken Northeast. Okay, Northeast Virginia region, let's say. But we will, you, for example, we are all working from home. You are there in your home, I'm there in my home. Okay, and we are located across different cities within India. So but we log into Snowflake. Okay, when we log in and when we submit a query, it will go to our Snowflake, where it is there we have taken from northeast region, let's say. We have configured our Snowflake. So it will go there. And first, when it reaches to that VPC means virtual private cloud. Means in data center, not only our client, right, our customer, right, there he is supporting hundreds of clients. So our request will go to our VPC. Okay, our VPC means, yeah. So the system setup are reserved for our use. Okay. So first it will get authentication and access control. It will check. It will check actually. Okay. This request is one of my subscribed user or not. For example, our company is X, right? So when we register with Snowflake, they'll provide one unique ID. Okay. So based on that, they will check. Okay, this user is already available or not. Yes, available. Okay, then they will allow. Okay, not everybody and anybody can access the VPC. Only the people who has taken Snowflake account. Okay, so they will be allowed. Okay, so that's called authentication and access control. Okay, so authentication means they validate the user. Okay, then okay, if he is already valid subscriber means valid Snowflake user, it will allow. And after that access control, he has access to, for example, I have admin access. Okay, you don't have admin access, then you will not be able to query everything. You will not be able to configure virtual warehouses. You will not be able to create certain things because you are not admin user. For example, I have admin user. Then I can create virtual warehouses. I can add virtual warehouse. I can delete virtual warehouse. Okay. So I can do all these admin activities. I can create another user. Okay. So I can do, or I can drop a user, or I can grant access to other users. So that is called access control. Okay. All admin privileges. So based on the user, I will have different, or in fact, the Snowflake will allow all those things. Access control. So all these things will be managed by cloud services layer. Cloud services layer. Okay, so that is okay. Cloud services layer will take care of authentication and access control and infrastructure manager. Infrastructure manager means provisioning the virtual warehouses. I said right. For example, I am an admin super user. I can create virtual warehouses. I can create two, or I can change from two to three, or I can drop the virtual warehouses. Okay, so or I can provision from 4 to 8. I can do anything. Okay, I can provision and unprovision virtual warehouses. So that is called infrastructure manager. Optimizer. Optimizer means actually it is a service within the cloud services layer. It will come up with the best plan actually. Okay, best plan means I will tell you optimizer is a very good actually. It is there of course in every cloud. For example, AWS will have Teradata has optimizer means it works based on the metadata. See, right side metadata is there. Metadata means it's data about the data. Means it will know what are the different tables I have, what are the different schemas I have. Okay, so what are the different for example, keys or indexes each table has, how much data they have. Okay, how large the tables are. So based on that information, it will come up with the best plan how to execute that particular query. That is called optimizer. What is the role of optimizer is it will come up with the best plan on how to execute a query. That is what optimizer will do. Okay, for example, you have queried some query, and it has some 20 tables, and 20 each table is something like 5 terabytes large, let's say, means very big table. Then this optimizer will come up with the best plan how efficiently it can run the query on the system. So it will come up with that, but because your data is across multiple virtual warehouses, right? Because your data is split across different virtual warehouses, and each one will work separately. Okay, it's not entire queries managed by one virtual warehouse. No. So this optimizer will come up with the best plan. Based actually in virtual warehouse also there are different types. Okay, large, 2x large, 4x large, so or 8x large, like that. So, and how many virtual warehouses you have? Maybe your cluster is, only one virtual warehouse, or it's made of two, or it's made of four. So based on all these things, means based on the current setup you have, the optimizer will come up with the best plan. Okay, actually, what is optimizer? Optimizer will come up with the best plan based on the available statistics. Statistics means whether the table is big or not, or whether the table is small. Okay, so how much data it has. Okay, so and how the tables are joined. All the data demographics about table data is called actually uh, data demographics. They only we call it as the statistic. Statistics means how the everything about this table, actually how the table is big or small, how they are joining columns has unique values or it has duplicate values. Everything it will see whether it has nulls or non nulls within the joining column. So based on that it will come up with the best plan. Okay, so basically in order to talk about optimizer will help to come up with the best plan. That's it. So metadata manager, metadata means it will store information about everything about that Snowflake. For example, we four of us are members of this X company, right? So it will store, okay, there are four users created on the Snowflake server. Okay, for example, Krishna and Monica, Harika and Arno. Okay, Krishna is the admin user. Monica, okay, and Harika, they are all normal users, they have only read access. Okay, and it has stored, okay, some 250 tables. Let's say I'm thinking if we have 250 tables, and it will store all the table names. Okay, customer, okay, so products, so all those things, and it has some 50 views. It will store all the views, and storage also the 250 tables, right? It will store, okay, each table how much size it has, and what are all the columns it has, everything. If there is a views, what are the views and what are the columns of those views, and who all has access to that views. All that information will be maintained by metadata. That is called metadata manager. That is managed by this manager. Okay, all that information is called metadata, and that is managed by this service. Okay, metadata manager. Actually, metadata textbook definition is metadata means data about data. So it stores the data about all these users data, okay, objects data like tables data, views data, all these things, or virtual warehouses data. Okay, everything, tables, table sizes, columns, everything will be stored in this metadata, and it is managed by metadata manager. And security service. Okay, security service will, for example, we have given different permissions to different users, right? And similarly in views also we give some restrictions to only certain users. We don't allow every user to access all the views. All the security restrictions whatever we applied, all those things will be managed by this security service. So those are all the different services within the cloud services layer. That's what is called cloud services. Means these are all services within that cloud services layer. What are those services? Authentication and access control, infrastructure manager, optimizer, metadata manager, security. These are all different services. So cloud services layer will have authentication and access control service, infrastructure manager service, optimizer service, metadata manager service, security service. So we don't say every time service. Everything is a service. That's why we call cloud services layer will have authentication and access control, infrastructure manager, optimizer, metadata manager, and a security. Okay, the security service will handle all the security related things within the Snowflake. Okay, cool. So once you heard this, so let us read like whatever he has mentioned. Anyway, this you can read later also. Okay, so that's not required. Or you say cloud services layer will have authentication, infrastructure management, metadata management. Okay, query parsing and optimization. You see, optimization layer we said, right? That one, optimization. Okay, so those are all different services. And query processing layer, what it will do. Okay, so query processing layer, anyway, let me see. What is this query processing layer? It will execute the query. Okay, for example, I said you have executed a query with 20 tables. Okay, and let's say some tables are 5 TB long, 5 terabytes of. Then that query is processed where? That query. So based on that query, optimizer will come up with the best plan. But actually, the query will be executed within the query processing layer only. So based on the whatever virtual warehouses has, everything will run that query. Okay. So and it will give the result. Okay. If the table is big, if the it will generate one plan. If the tables are small, it will generate. So that's why the planning is optimizer's job. Okay. So as per the optimizer's plan, the virtual warehouses will execute the query. So let's see. Query execution is performed in the processing layer. Snowflake process queries using virtual warehouses. See, who will execute the queries or who will process the queries? Virtual warehouses. I said, what are virtual warehouses? Virtual warehouses are the like process. Okay, we call virtual warehouses here. Each virtual warehouse is in a MPP computer cluster. Okay, each virtual warehouse is an MPP compute cluster composed of multiple compute nodes allocated by Snowflake from a cloud provider. Okay. So I said, right, each virtual warehouse is like a MPP system. MPP means massively parallel processing. Okay. MPP means massively parallel processing. And it will have multiple, CPUs, IO, and RAM. It has its own CPU, IO, and RAM. And of course, it can have multiple CPUs. Okay. Based on you are using X large, 2X large, 4X large, 8X large node types. Means see, X large means you may have only two cores. Cores means CPU. Okay. 2X large means you may have four cores. 8X large means you have eight cores. Why these are different 1x, 2x, 4x, 8x? Because there are some customers who process very huge data. Okay, for them we need more capacity. So different customers will use different based on how much data they have. Okay, I have seen the customers having thousands of terabytes of data. For them, this 1x, 2x, 4x, these are not sufficient actually. They need 8x and 16x, you know, the virtual warehouses. So yeah, that's why they have set like that. And based on the client needs, based on their compute requirement, they will select whatever virtual warehouses they need. So that's why each virtual warehouse is an MPP. MPP means massively parallel processing, where each node has its own CPUs, IOs, and memory. Okay. So and they also will work parallelly within the each virtual warehouse. Okay, they also will work parallelly within each virtual warehouse. These are all for purpose of parallelism. Each virtual warehouse is an MPP, okay, compute cluster composed of multiple compute nodes allocated by Snowflake from cloud provider. Okay. Each virtual warehouse is an independent compute cluster. You see, each virtual warehouse is independent. Means I said right, they will work parallelly. You may have two virtual warehouses and two will work separately because they have their own CPU, IO, and main memory. Okay, each virtual warehouse is an independent compute cluster that does not share compute resources. You see, that does not share compute resources means they have their own CPU, IO, main memory. That's what. Okay, one virtual warehouse does not depend on other. Okay, for its CPU, IO, main memory. No, each virtual warehouse is an independent compute cluster. Okay, and it does not share its compute resources with other virtual warehouse. Okay, so as a result, each virtual warehouse has no impact on the performance of other virtual warehouse. That means each is independent. Each can work on its own. That's what the point here. Okay, query processing layer. Okay, it processes the queries that are submitted to the Snowflake, and it has multiple virtual warehouses. Each virtual warehouse is independent, and it has its own compute resources like CPU, main memory, and IO. So each virtual warehouses is independent. It does not dependent on other virtual warehouse. So These are all for improving query performance. Why or how? Because each virtual warehouse is capable of doing its own job. You don't have to depend on others. So it will improve the parallelism, because if you have four virtual warehouse will work independently parallelly. That's it. For example, I am one virtual warehouse, you are one virtual. If we four of us, four different virtual warehouse, let's say, and we have our own CPIO, then if a task is given, okay, the task will come to four of us, and we just do independently. That's it, and we'll just give the result back to the actually work is assigned by actually cloud services layer only. Okay, the authentication access control. Okay, the optimizer, actually the work will come here from cloud services layer to query processing layer. So once we all virtual warehouses processed their data, they will give the result set to the cloud services layer again, and cloud services layer will give back to the client where the query fired from. Okay, so that is the way it is. So for example, here my cursor is there, right? There we are end users. We run the query. Our query will come through TCP/IP to authentication layer, and once we have all the access and permissions, okay, it will come to the optimizer. Optimizer will come up with the best plan. It will come to the virtual warehouses. Virtual warehouses will process the data and will give the data back to the cloud services layer. Okay, and cloud services layer will give back to the end users. Like that, the data processing will happen actually. So let's say, because yeah, so yeah, that's about query processing. So let's say about what is database storage layer. Database storage layer is loaded into Snowflake. Okay, Snowflake reorganizes the data into this internal optimized compressed columnar format. Okay, yeah, I need to tell a few points here. All the storage within the cloud is compressed storage, and all the clouds are columnar format. Okay, I will tell you, okay, separately after explaining this. Okay, all the storage within the cloud is in compressed format, and it's stored with columnar format. Okay, when that is loaded into Snowflake reorganizes the data into its internal optimized compressed columnar format. Snowflake stores this optimized data in cloud storage. Yeah, so basically, where the data is stored in cloud storage means the third layer, database storage layer. Here only all your data is stored. And how it is stored? It's in compressed format, and it's in columnar format. I will tell you what is compressed and what is columnar. So okay, Snowflake stores this optimized data in cloud storage. Okay, Snowflake manages all aspects of how this data is stored: the organization, file size, structure, compression, metadata, statistics, and other aspects of data storage are handled by Snowflake. The data objects stored by Snowflake are not directly visible nor accessible by customers. Yeah, they are only accessible through SQL query operations run using SQL. He is telling the data we can only access through SQL. Yeah, that's what everywhere it's same. Okay, data is stored in storage layer, but how can you access the data? You can only access through SQL queries. Okay, you can only access through SQL queries. Okay, but the data is stored. Okay, anyway, let me first write the layers in data warehouse and layers in cloud. Okay, Snowflake has, now I'm summarizing the entire thing that we learned. Okay, Snowflake architecture. Snowflake architecture has three layers. What are those? Cloud services layer, warehouse layer, or what is that virtual warehouse layer? It's query processing layer.
Very proud.
Yeah. Okay. Query processing layer, and third one, database storage layer.
Database storage.
So these are the three different layers. Okay, cloud services layer, query processing layer, and database storage layer. Okay, so we'll go one by one. In cloud services layer, it will have different services. Okay, for authentication and access control, for infrastructure manager, for optimizing, for better metadata managing, and for security management. Okay, those are all services. Services means some software will be there that will take care of. What are all the activities? Authentication and access control. Authentication means whether the user has access or not to Snowflake, because we are not supposed to allow anyone, everyone, right, to our cluster. So it will make sure the users are coming from the authorized customer. For example, Snowflake has multiple customers, so it will assign one unique ID for each customer, and it will validate. Okay, he is coming from this customer. He is coming from this customer, like that. So authorization and access control. Once he is authorized, then he should be able to access only the allowed objects. Means if he is a user, he should access only his whatever granted objects like table service. If he's admin, he's able to create provision virtual warehouses, unprovision them, and grant or create users, and granting access to the users or revoking access to users, all those things based on that, what type of user he is able to do his own activities. So that is authorization and access control. Then infrastructure manager, like provisioning and unprovisioning of the virtual warehouses. And my optimizer will come up with the best plan. Okay, and of course it will use metadata from the metadata manager. Okay, metadata means it will store all the objects. Okay, how many databases are there, how many tables are there, how many views are there, what is their size, how big they are or how small they are, how many unique values it has, how many nulls they have. So every information about the what is stored in that Snowflake will be there in this metadata manager. Okay, using this metadata only, optimizer will come up with the best plan. Okay, and the last one is security service. Security service will ensure, okay, whatever the security restrictions we put, okay, for users or for even for views, everything will be working as expected. No unauthorized user will be accessing that, because sometimes in views we'll be creating some secure views, or sometimes we'll be applying some restrictions. All those things should be properly following or not. And in fact, it is managed through security service layer, security service within the cloud services layer. Okay, so query processing layer. In query processing layer, we should talk about virtual warehouse. Okay, so in query processing layer, we will have virtual warehouse. Okay, we can configure different virtual warehouse. Okay, like x large, 2x large, 4x large, 8x large, and each virtual warehouse has its own resources like CPU, IO, and main memory. Okay, and each virtual warehouse, since it has their own resources like CPU, IO, and memory, they are independent. Okay, they work independently. They work means they process the queries independently. Okay, if you are given, for example, select star from table name, and the select star from table name will go to all the virtual warehouses, and all the virtual warehouses will work and give the data that each virtual warehouse has. Okay, all the virtual warehouse will work parallelly. So that's where the parallelism. All cloud data warehouses are based on distributed systems. Distributed systems means your data is not in one disk, it is distributed across multiple disks. So that, for example, you see we four are there. If a work is given, if four of us will work parallelly, then it will complete faster. If only one person is working, then it's not fast across them, so that they each can process their own work independently and complete it faster. So virtual warehouse, okay, are basically the computing units which has their own CPU, IO, and RAM, and they are capable of doing their own processing independently. So they are not dependent on other virtual processors, resources, or performance. Okay, so they will complete their work quickly. So in that way, they will improve the query performance. Okay, so basically, query processing layer is responsible for processing your queries. Okay, so how they'll process? They'll have different virtual warehouses, and each virtual warehouse has different cores. Actually, cores means CPU. Within the virtual warehouse, you will have, based on whether it's a X large, 2X large, 4X large, it has different CPUs within again. So they will process. The higher the configuration, the more powerful cores will be there. Cores means CPU units. Okay, some large customers will use larger cores like 4X, 8X, 16X. Small customers will have something like large 2X, 4X virtual warehouses. Okay, basically the purpose of query processing layer is it processes the queries that are submitted. Okay, so here authentication and access control. Infrastructure manager. Infrastructure manager. Then what is that? Optimizer.
Optimizer.
Metadata manager.
Manager. Security.
Okay, so these are the different services handled by cloud services layer. Okay, then what query processing layer will take care of the query processing. Okay, so then database storage layer is responsible for storing the data. Okay, it stores the data. It stores the data in compressed columnar storage. Okay, I'll tell you what is this compressed and what is this columnar storage. Okay, and responsible for storing the data. Okay, so if you see the architecture, see database storage layer, all your data is physically stored here. Okay, that's why it is storage layer. Okay, so within this layer, data is stored in a compressed format. Compressed means, right, in zip, in our laptop, if any file is big, we'll zip, right? So like that, the data is stored in a compressed format. Okay, in compressed also there are like gzip, we use it, right? Like that, it will have snappy. In the real time also, compressed is there. Okay, but that is at the table level. Okay, our data we are loading into table, right? That table, but that is stored. For example, in the Excel sheet, it is Excel. Okay, in the table, it is table. But in the cloud, when we load the data, it is stored within the. For example, you are using wait, this, right? This Snowflake. I already said Snowflake will be hosted on AWS or AWS, Azure, or GCP. So when we host this will actually, if it is AWS environment, this is stored, okay, S3, S3. Okay, if it is GCP, it is uses Google Cloud Storage, GCS. If it's Azure, it is Blob Storage. Okay, means Azure storage name. So there basically it is stored within that S3 actually of the corresponding service. Okay, so there it is to actually it is there in the file format only. Okay, file format. So that file is actually stored under compressed format. Okay, compressed means it's like gzip, snappy. There are different techniques. So snappy is the most widely used in real time. These are all automatic. Okay, we cannot see. That's why it is mentioned here in storage layer. It is mentioned. What is mentioned? It does not directly visible or accessible by customers. Okay, you cannot see it. Okay, this is only for learning purpose. Okay, so the data objects stored by Snowflake are not directly visible or accessible by customers, but you can access through queries only. Okay, they are only accessible through SQL query. Okay, this is only for learning that Snowflake stores the data, okay, in a compressed and columnar. Okay, I want to see means we cannot see. Okay, so this is only for learning. For example, our body inside, let's say we have intestines and all, right? Okay, they will be, it will be there in a different local. Okay, different we know that they are there. If we want to see means we cannot see, right? You only know how they function, that's it. Our body organs, internal organs. Similarly, these are all there and they store the data, okay, in a compressed format, and they store the data in a columnar format. That's it, you can only learn. And if you want to see, you can only query them. You can only query them through SQL queries. That's it. So basically, database storage layer is responsible for storing the data, and it stores the data in a compressed and columnar format. Columnar format. Okay. So now, what is columnar storage? Columnar storage means, for example, if I have employee table have employee name, department number, and salary, right? Okay. Row level storage means this entire record will be stored. It may have some 100, okay, some employee ID 1, name, salary, department number 10, salary 10,000. So all the record will be stored in the disk, entire record. That is row level storage. Entire record will be stored in the row. That is row level storage. Entire record. So in fact, all traditional databases are this row level storage. Means entire record. So let's say you want select star, you want employee number, 1. Then if you want to give select star from table where employee ID 1, then this record will come, right? So it has to fetch the, because it stored the entire record in the disk, so it has to fetch the entire record into memory, and then it has to take whatever salary. For example, I want salary from employee where employee ID equals to 1. That means what is your output? You need 10,000. I want salary only. Okay, select salary from employee where employee ID equals to 1. Means you want output 10. So, but while query processing, the entire record is stored in the disk. So it has to fetch the entire record from disk to main memory, and from once it fetches the entire record, it will take this 10,000 and it will give. That means what is that unnecessary it's doing? It's unnecessarily taking the entire record from disk to main memory, and from there it is taking the this 10,000. So that is the disadvantage of row level storage. Row level storage will source the data row level, means entire record will be stored. So for everything you need to copy the entire record into main memory and process. So there is a lot of IO will be wasted, input output. So what cloud data warehouses did is, they don't store like this row level. They store all employee IDs. 1, 2, 3 means these are all different employees. So they will be stored in the disk. Similarly, okay. So names, all names will be stored separately in the disk. Okay, RAM, SAM, whatever it may be. Okay, so all names will be stored separately in the disk. Similarly, all salaries will be stored separately in the disk level. Means columnar, this is called columnar storage. Columnar storage means all column values are stored separately, like that. So whenever you want salary, select star from table name, or select salary from table where employee ID equals to 1, it directly come to this particular block where this 10,000 is stored, and it will get the data. That means only this 10,000 value it will bring to main memory from this disk, and it will give the data. Okay, that means with column level storage, you are not unnecessarily fetching data from storage to main memory. So in that way, it is saving lot of IO. Okay, so that's why all cloud services will be using columnar storage. Actually, this also they will ask actually, what is columnar storage? Columnar storage means Snowflake will store the data at the column level. Okay, because of this, we can save a lot of IO. What is row level storage? All traditional databases store the data, entire record will be stored in the disk. But let's say a table has 250 columns. Generally, we select 1, 2, 3, 4, 5 columns. But for getting these 5 columns, you have to bring the entire 250 columns into main memory, and then you have to select these 5. So there is a lot of IO is wasted. It's a known issue actually within the databases. So they have fixed it in this cloud data warehouses by changing the storage from row level storage to columnar storage. In columnar storage, only individual columns will be stored at the disk level. Okay, all employee IDs will be separate, names will be separate, so okay, salaries will be separate, and department numbers will be separate, like that. Means each columns will be stored separately, and they will be stored compressed way. Okay, they will be compressed and stored. So whenever you want any, for example, you want salary, then it will directly go to the block where the salary values are stored, and it will get the data. Let's say you want the department number, it will directly go to the block where department numbers are stored, and it will get whatever department you want. So that's why it is called columnar storage. Okay, so everything will be taken care by this database storage layer. Okay, so database storage layer is responsible for storing the data. Okay, it stores the data in compressed and columnar format. That's it. So in this class, you should be knowing about what is shared disk. Shared disk means the disk is available to all virtual warehouses. Shared nothing means all virtual warehouses will have their own CPU IO in main memory, and they are able to work independently on their own. Actually, shared nothing is nothing but MPP. MPP is only called shared nothing actually. Okay, so actually, yeah, then you will know. Okay, shared nothing means actually MPP architecture means each node has their own CPU IO memory, and they will work independently. And then Snowflake architecture. Snowflake architecture, you need to know about these 3 layers: cloud services layer, query processing layer, database storage layer. That's it. So once you explain this, this is the initial question. Okay, while explaining database storage layer, we have to touch about compressed format and columnar format. That's it. In the end, you have to touch about row level storage and columnar storage. So these are the terms we have to talk while explaining to the user. Then he will know that yes, he is a solid candidate. He knows all the technical terms. Okay. So anyway, these two are not required. SMP and distributed systems actually. Yeah, this is only for information purpose, not required actually. Yeah. So yeah, you should be knowing all the 3 layers and what each layer will be doing. Okay. So do a lot of study and rehearsal. Rehearsal is important. Even you may know it, but how you present actually matters. Okay, so any questions you have? Do you have any questions? Or if no questions, we can close the session.
So one thing like um,
Thank you, Krishna.
Yeah. Thank you. If we are done, you can go. Okay. If you don't have any questions. Yeah. Arno, tell me.
okay. In Redshift, like that metadata manager is only the difference, right? Compared to Redshift.
No, metadata.
Mostly other things are like same, if I'm not wrong.
Yeah, you see, all these services are same actually. Okay. See,
Okay.
metadata manager means what? It stores about all the objects, their information, and everything. Okay. Yeah, it is same. Where you're talking about in Redshift only, right?
Yeah.
Yeah, these all will be there everywhere because everywhere metadata is there, right? Everywhere they have to maintain, objects, information, everything. Yeah, that is same.
Okay. I thought okay.
Yeah,
Yeah.
because optimizer will be there also, metadata will be there. Yeah, they all will be maintained by, the separate services within. But here he has clearly, highlighted in the architecture, okay, what all we have in cloud services layer: infrastructure manager, optimizer, metadata manager, security. There he don't actually highlighted that. Okay, he just say that we have ladder node, we have compute node and all. Ladder node will do all these things actually there. Here it is cloud services layer will do. Clear?
Yes. Correct. Yes.
Yeah. Okay then, see you tomorrow.
Yeah. Okay. Sir. Yeah. Thank you.
Okay, take care. Bye.